We noted before, though, that Java treats different data types differently. Well, what about Python? Let's check how Python handles strings. That's a different kind of data. So this code is pretty much identical. As before, we create a new function. The body of the function is initially skipped, but we can see that the function changes the value of the string it's given to itself plus an exclamation point. It adds an exclamation point to the end of whatever string is passed in as an argument. So our code runs. It creates the string hello world with no exclamation point. It prints it so we can confirm that there is in fact no exclamation point. Then it runs that function. Calling that function sends execution into that function where it modifies a string and adds an exclamation point and then prints it. Sure enough, we see that when it's printed from inside the function, it has the exclamation point. We can tell it's being printed from inside the function because it's preceded by the label a string. So we can tell that this output corresponds to the print statement inside the function. Then once it's done, execution returns to the next line of the main program. It runs line 9, and we see that the value of hello world hasn't changed. After calling addExc, there is no exclamation point on hello world. So it appears that strings are being passed by value as well. The function addExc could only change its local copy of that variable, not the one that it was given, or not the one from which the value came. But strings are still a relatively primitive data type. Let's try something even more advanced. Let's try a list. This code is effectively the same again, just with a list instead of a string or a number. Line 2 defines our function, and the goal of this function is just to add one new item to the list. It'll be a string that says new item. The list.append method just takes whatever is in parentheses and adds it to the list. It's the equivalent of your friend or spouse yelling to you, hey, add milk to the grocery list. Our main code runs, and it creates a list called mylist with 3 items, 1, 2, and 3. We print the list and see that sure enough, those are the only 3 items in our list. We then run the function, which kicks execution up into the addItem function. It runs line 3, appends new item, runs line 4, and prints the list. And sure enough, we see that inside the function, a list is 1, 2, 3, and new item. New item has been added to the list. The list is defined by the brackets, so because new item appears inside the brackets, it's been added to the list. Now the function is done, so execution returns to the main program and runs line 9. But here's something weird happens. When we print on line 9, when we print the list after that function, new item is here. So that means that this function actually was able to modify the original list that we passed into it. Here we were clearly passing by reference. We were giving the function access to the original variable to modify it. And then when we access that variable again, we see the modified value. This is the equivalent of handing Addison a paper with the number 5 on it and having him give it back to you later. He could change the value while he has it. So this seems to mean that Python passes primitive data types like integers and strings by value and advanced data types like lists by reference, right? And as I said before, practically speaking, yes. That seems like it's what's happening, and in fact, functionally, it's as if that's what's happening. Accurately speaking, though, no. The ultimate effect here is that it's as if Python is passing these primitive data types by value. But in reality, something different is going on. Python has something called immutable data types whose values cannot be changed. That gets pretty tricky on its own, though, so we're going to hold that for the next lesson. For now, it's sufficient to know there are some data types for which Python effectively passes by value, but for the majority of data types, Python passes by reference. When you send a variable into a function, the function can modify your copy of that variable.